Hello students, welcome back to video lecture series of Maths for class 12th. In last lecture, we studied about different type of relations. In this lecture, we will study about different type of function and composition of function. Let us start with functions. A relation f from a to b is called a function if every element of a is related to a unique element of b. Another definition is, in other words, we can also call it a mapping f from a to b which associates every element of a to a unique element of b is called function. A function f from a to b is denoted as f from a to b. If f associates an element of a belongs to a to b belongs to b, then it is denoted by f of a equal to b, where b is called image of a and a is preimage of b. If f is a function from a to b, a is called domain of the function, b is called codomain of the function, and set of images that is called range of the function. Let us take an arrow diagram to explain function, its domain, codomain and range. Let A is the set of 3 elements A1, A2, A3, B is another set of 4 elements B1, B2, B3, B4. F is a mapping which relates element of A to element of B such that f of A1 equal to B1, f of A2 equal to B2 and f of A3 equal to B2, where B1 is called image of A1, B2 is image of A2 and B2 is also image of A3. In other words, we can say A1 is preimage of B1, A2 is preimage of B2 and A3 is preimage of B2. In this example, domain of the function f is set A which contains elements A1, A2, A3, codomain of the function is set B and range of the function is set of 2 elements B1 and B2. There are different type of functions such as 1-1 function which is also called injective function. A function f from a to b is said to be 1-1 if different element of a have different images in b. Means a function f from a to b is 1-1 if f of a1 equal to f of a2 implies a1 equal to a2, or we can also call it f of a1 is not equal to f of a2 implies a1 is not equal to a2. So, for this we can take one arrow diagram. A is the set of 3 elements a1, a2, a3, b is another set with elements b1, b2, b3, b4, f is a relation from a to b, then a1 is related with b1, a2 is related with b2, a3 is related with b3. So, one element has only one image. So, we can say this function f is 1-1. Let us take another example. G is a function from a to b where a is set of 2 elements a1, a2, b is set of 3 elements b1, b2, b3 where a1 is related to b1, a2 is also related to b1. So, in this case we can say b1 has 2 preimages a1 and a2. Therefore, G is not a 1-1 function. So, to check 1-1 function, we can take another example. Let f is a function from set of natural number to natural number such that fx is defined as fx equal to x square. For 1-1 function, let f of x1 equal to f of x2. This implies x1 square equal to x2 square. This implies x1 square minus x2 square equal to 0. We factorize it, means x1 minus x2 into x1 plus x2 equal to 0. x1 plus x2 cannot be 0 because sum of 2 natural numbers cannot be 0. Therefore, x1 equal to x2. Now, we are taking f of x1 equal to f of x2 and x1 is coming equal to x2. Therefore, f is 1-1 function. Let us take another example. F is a function from real number to real number such that fx equal to x square. We take f of minus 1 which is 1, f of 1 is also 1. That means image of minus 1 is 1, image of 1 is also 1. That means 2 different elements, they have same images. So, this function is not a 1 function. Next type of function is onto function, which is also called surjective function. A function f from a to b is said to be onto if for all b belongs to b, there exists at least one a belongs to a such that f of a equal to b. In other words, a function f from a to b is said to be onto if every element of b have at least one pre-image of a. Let us take an arrow diagram to explain onto function. Let A and B are two sets, A with 3 elements A1, A2, A3, B with 2 elements B1, B2. A1 is related with B1, A2 related with B1, A3 related with B2. In this example, there is no element in B which is not related with any element of A. Therefore, we can say this function f is onto function. In other words, a function f is said to be onto if codomain of f is equal to range of f. Let us take example to verify whether a given function is onto or not. Let us take f is a function from set of real number to real number such that f(x) equal to x cube plus 2. So, to prove function is onto, let us take y equal to this function x cube plus 2. Now, we find value of x in terms of y. We can take x cube is equal to y minus 2. X is given by y minus 2 to the power 1 by 3. For y belongs to R, which is codomain, y minus 2 is also a real number. It also belongs to R. Y minus 2 to the power 1 by 3 is also real number. Therefore, for y belongs to codomain real number, there exists x belongs to domain real number such that f(x) equal to y. Therefore, f is onto function. Let us take another example. A function f from set of natural number to natural number such that f(x) equal to x square. So, for this we take y equal to x to the power 2. If we take y equal to 2 belongs to set of natural number, there does not exist any x belongs to natural number such that f(x) equal to y, means there does not exist any natural number whose square is 2. So, in this case we can say f is not a onto function. Next is bijective function. We can also call it 1 and onto function. A function f from a to b is bijective if and only if f is 1 and onto both. To explain bijective function, let us take one arrow diagram. A and b are two sets. A is a set of elements a1, a2, a3. B is a set of elements b1, b2, b3. A1 is related with b1, a2 is related with b2, a3 is related with b3. This mapping is, or this function is 1 because every element of A is related to a unique element of B. This function is also onto function. So, we can say this function is bijective function. In case of bijective function, number of elements of A should be equal to number of elements of B. Let us take another example to explain bijective function. A function f from set of rational number to set of rational number such that f(x) equal to 2x minus 3. Now, we have to check whether this function is bijective or not. Means to prove this function is bijective, this is sufficient to prove this function is 1 and onto. So, for 1 function, let us take f of x1 equal to f of x2. This implies 2x1 minus 3 equal to 2x2 minus 3. This implies on simplification x1 is coming equal to x2. So, this function is called 1 function. For onto function, let y equal to 2x minus 3. This implies x is equal to y plus 3 by 2. Let y belongs to set of rational number. Therefore, y plus 3 by 2 also belongs to set of rational number. So, we can see for y belongs to Q codomain, there exists x belongs to Q domain such that f of x equal to y. Therefore, y f is onto function. This function is 1 and onto both. Therefore, this function is bijective function. Let us take another example for bijective function. A function f from R to R such that f(x) equal to 3x cube plus 5. Now, we have to show whether this function is 1 and onto. For 1 function, let f of x1 equal to f of x2. This implies 3x1 cube plus 5 equal to 3x2 cube plus 5. On simplification, x1 is coming equal to x2. Therefore, f is 1, 1. For onto function, let y belongs to R. Y can be written as y equal to 3x cube plus 5. X cube can be written as y minus 5 by 3, and x is equal to y minus 5 by 3 to the whole power 1 by 3. Let y belongs to R, which is set of real number. Y minus 5 by 3 is also a real number, and cube root of real number is also real. Therefore, for y belongs to R codomain, there exists x belongs to R domain such that f of x equal to y. Therefore, y is onto function. Now, y is 1, 1 and onto both. Therefore, y is bijective function. Let us take another example for bijective function. Let f is a function from n to n such that f of x equal to x square. For bijective function, a function should be 1, 1 and onto both. We take fx equal to x square. For 1, 1, f of x1 equal to f of x2. That means x1 square equal to x2 square. This implies x1 equal to x2. This function is 1, 1. For onto function, we can take one example. For y equal to 2, there does not exist any x belongs to set of natural number for which fx equal to 2. So, this function is not an onto function. So, this function is 1, 1 but not onto. Therefore, this function is not a bijective function. Next is composition of function. Let f is a function from a to b, g is a function from b to c. This implies g naught f is a composition from a to c such that g naught f of x equal to g of fx for all x belongs to a. Composition of two function g naught f is defined if range of f is a subset of domain of g. Let us take example to explain composition of function. If f is a function from R to R, g is also a function from R to R such that fx equal to 3x square plus 2 and gx equal to 4x minus 5. Find f naught g. For f naught g of x, this is equal to f of gx. Gx is replaced by 4x minus 5. So, this is equal to f of 4x minus 5, which is equal to 3 times 4x minus 5 whole square plus 2, which is equal to 3 of 16x square plus 25 minus 40x plus 2, which is equal to 48x square minus 120x plus 77. We can also find g naught f for this same function. G naught f of x, this is given by g of fx, which is equal to g of 3x square plus 2, which is equal to 4 times of 3x square plus 2 minus 5. On simplification, this is coming equal to 12x square plus 3. So, now we can say fog is not equal to gof, means f naught g is not equal to g naught f always. In this lecture, we studied about different type of functions, that is injective function, surjective function and bijective function. In our next lecture, we will continue with invertible function and how to find inverse of a function. Thank you.